So you just spent some time reviewing simplifying fractions, which is a skill that is not new. You have worked on this skill in 6th grade, in 5th grade, in 4th grade. Having great number sense helps us in math. Being able to work with numbers and see how they relate to each other is really helpful in math. So there's nothing you need to write down in your notes here, just watch. If I want to simplify the fraction 12/30ths, I can think about what is the greatest common factor 12 and 30 share. If I'm not sure if it's the greatest common factor, I can still use it as long as it is a common factor. It might just take me a little bit longer to get to the simplest form. Well, I know 2 is a common factor of both of these. I know 3 is a common factor of both of these. Therefore, since they share the factor 2 and 3, bringing back my divisibility rules, if a number is divisible by both 2 and 3, it's also divisible by 6. So I'm going to use 6, because that one, 6 is bigger than the 2 and the 3. So I'm going to divide by 6, divide by 6. That's going to give me 2/5. 2 and 5, the only factor 2 and 5 share right now is 1. So this is the simplest form of 12/30ths. Let's look at finding the simplest form of a fraction in a different way, using prime factors. Still focusing on factors, but this time they're going to be the prime factors. So if I find the prime factorization of 12 and 30, I'm going to use factor trees to help me do that. 2 factors of 12, I cannot use 1 in 12, right? Because 1 is neither prime nor composite. Let's see, 2 and 6. 2 is prime. I can break 6 up into 2 times 3. So my PF for 12, my prime factorization would be 2 times 2 times 3. Looking at 30, I know 30 is divisible by 5 because it ends with a 0. So 5 times 6. 5 is prime. Its only factors are 1 and 5. 6, I can break 6 up into 2 times 3, and they are both prime. So the PF here would be 2 times 3 times 5. So here was my numerator, the prime factors for my numerator. Here are the prime factors for my denominator. Do my numerator and denominator have some common factors? Yeah. Now remember, this fraction bar represents a division problem, right? So 2 divided by 2, well, that gives me a 1, and they just cancel each other out, right? Because any number times 1 is that number. So if there's a 1 up here, it's okay. It doesn't change the value of anything. This 3 and this 3 cancel each other out. All I'm left with on the top is a 2 and a 5. 2/5. What we got over here as the simplest form for 12/30ths. So using prime factors and recognizing that I can cancel. And when I go a number divided by the exact same number, that gives me 1. And having the factor of 1 is okay because anything times 1 is that number. Now, let's dive into how simplifying fractions looks in 7th grade. You already know a lot about simplifying fractions, so let's use what we already know to help us with simplifying fractions that include variables. Find the last chunk in your notes titled More Examples with Variables. Write down your first problem here. We are going to simplify this expression. So 6x squared divided by 4. What is a common factor? I know that you see the 6 and the 4. You see the 6 in the numerator, the 4 in the denominator. That should feel comfortable to simplify, right? What does a factor 6 and 4 share? They share 2. So I can divide the numerator by 2 there and the denominator by 2 there. 6 divided by 2 is 3. 4 divided by 2 is 2. That part I'm comfortable with. This part right here, x squared, I don't have anything to simplify that with on the bottom, so it just remains x squared. Here's the simplified version of our original expression. Not too different. We used what we already knew how to do with simplifying fractions. Go ahead and write down example 2. We have 28 times n cubed divided by 42n. Remember, when you have a number directly next to a variable, it means multiply. Remember, powers, we can write them out in expanded form. They're just repeated multiplication. So start by using what you already know. 28 divided by 42, you can pull out a common factor. What is a common factor 28 and 42 share? Well, you might go, I'm not sure I know what the greatest common factor is, Mrs. Kluver, that they share. Well, go with a factor that you know they share. Maybe you're thinking, I know they share 7. So you're going to divide them both by 7. Okay? When I do that, I'm going to get 28 divided by 7 is 4. 42 divided by 7 is 6. And then I'm just going to keep, but what I'm noticing is 4 and 6, I can simplify that further. What can I divide 4 by? So I'm just going to go like this and rewrite my problem. What can I divide 4, or what common factor can I divide 4 and 6 by? I can divide them both by 2. So see, I didn't use the greatest common factor right away, and that's okay. It's helpful when you use the greatest common factor because you get there a little bit faster. See, I have to do another step here. So 4 divided by 2, I'm going to go down here a little bit, gives me 2. And 6 divided by 2 gives me 3. So then I'm just going to see how I have n cubed here and n. Let's take this power and let's write it out in expanded form. So on the top, it would be 2 times n times n times n. When you have a variable directly next to a variable, it means multiply. On the bottom, I just have 1n. So all I did is I took my power and I wrote it out in expanded form. 2 and 3, the only factor they share right now is 1. So those two values are simplified, but my n's, n divided by n, n divided by n, it's like when you have 4 divided by 4, what does that give you? 1, the factor 1. We want to find those factors of 1 when we're doing this. So n divided by n just gives me 1, factor of 1. I don't have any other n's on the bottom to cancel the top ends out with, so it just stays as is. Can we write this a little bit more succinct, to the point? Yes, we could. We have 2 times n times n. This n times n, I can raise that to the second power, right? N is being used as a factor twice there. So I can write my final problem as 2n squared divided by 3. And this right here is the simplified version of our original expression. Let's go ahead. We have 2 more examples to do with simplifying fractions, including variables. We have example 3 and example 4. Let's write those down together. So example 3, here we go. A to the 4th power times b times c cubed over a times b squared times c squared. How is this one different than our first 2 examples? Well, there's no numbers. The only numbers that are here are exponents, right? My variables, I only am dealing with all variables. So here's what we're going to do. We're going to write it all out in expanded form and see if we can pull out the factor 1. Use that factor 1 idea. We're dividing and things are canceling out. So here we go. If I write it out in expanded form, a to the 4th power looks like this. A times a times a times a. I only have a b, and then c cubed is 3 c's that I'm multiplying together. Times c times c times c. All over, I only have 1a, b squared, so that's times b times b, times c squared, so times c times c. Now, can I cancel anything out? Meaning I'm getting that factor of 1. We expanded out all the variables. Can we look for factors of 1? Well, right here, a divided by a would give me a factor of 1, right? So those cancel out. I don't have any more a's on the bottom. I have a b on the top, a b on the bottom. Those cancel out. I have 3 c's on the top, 2 c's on the bottom. So that pair of c's cancels out. This pair of c cancels out. Gosh, what am I left with? I'm going to step down here. I'm left with a times a, which I can write as a to the 3rd power, or a cubed, times c, all over, what do I have on the bottom here? B. Do you notice how I just have A on top, C on top? I don't have A or C on the bottom, and on the bottom I just have B. That's what we should have. When we get to the simplest form, there shouldn't be an A on the top and an A on the bottom. Then I didn't find that factor of 1. There shouldn't be a C on top and a C on the bottom, and there shouldn't be a B on top and a B on the bottom. Let's do our final example with simplifying fractions, including variables. All right, write down our final example. We have 6 times x squared times y times z divided by 54x cubed times y squared times z. And remember, when you have a number directly next to a variable, it means multiply. When you have a variable directly next to a variable, it means multiply. All right? So let's start by using what we already know. Our last example, we just had variables present. This example, I see some numbers and I can simplify those numbers because they share a common factor outside of 1. So I'm just going to put my line in there to help isolate what I'm looking at. 6 and 54, what is a common factor they share outside of 1? 6. I can take 6 and divide it by 6. I can take 54 and divide it by 6. So that looks like 6 divided by 6 is 1 over 54 divided by 6 is 9. I am left with now x squared. Let's take any powers and write them out in expanded form. So x squared is the same as x times x. So 1x times x times y, I'm just taking what I have up here, times z. If it's a power, I'm going to put it in expanded form. So going to my denominator, x cubed, that's x times x times x times y squared, that's times y times z. Oh my goodness, I have to expand my fraction bar there. Oh boy. All right. I see that I have an x on top and an x on the bottom, so I can cancel those out. Ms. Clover did not draw a very straight line there. I can cancel those out. I have another x on the top, another x on the bottom. I can cancel those out. I have an x on the bottom. I don't have any more x's on top, so I can't cancel those out. Remember, when I'm canceling it, I'm finding that factor of 1 because a number divided by the exact same number gives you 1. Whether we know that variables take the place of numbers, right? So same thing here. When you're taking a variable and dividing it by the same variable, it's going to give you 1. So looking for that factor of 1. A y, do I have a y on the bottom? Yes, I do. So those are going to cancel out. Z on top, z on the bottom, those are going to cancel out. Oh my goodness, there's a lot going on up there, isn't there? So I have 1, that's all I have left on top, over 9. That is canceled, that is canceled, that is not, and that is not x, y. Oh my goodness. This is the simplified form of our original expression. Take a moment to think about what we just did, right? We simplify like we know how. The 6 and the 54, I know how to simplify that. I'm thinking of what is a common factor between those two values. Then, if we had powers, we wrote them in expanded form so that we could look for that factor of 1. Where I have an x on top divided by an x on the bottom, I can create that factor of 1, meaning it's gone. I cancel it out of there. And again, we shouldn't have, if I have an x on the bottom in my final answer, I shouldn't have an x on the top. If I have a y on the bottom in my final answer, I shouldn't have a y on the top. My z's canceled out altogether. This is how we take simplifying fractions to that 7th grade level. Take a moment to now tell yourself, have a conversation with yourself and answer this question. How do we simplify fractions with variables? Look back at our 4 examples, or maybe you need to rewind a portion of this video.